Hey guys, Catlin here with your help for your homework in algebra. We're looking at lesson 17 here where we're compounding different intervals of loans or bank accounts, savings accounts, that kind of stuff. And we got a savings account that pays 3%. Now, this is important here. They tell you a really important word. They use nominal. Okay. So if it's a nominal annual interest rate, they're telling you that over the course of that year, 3% is what's coming out. And if they start to break it up into portions like half the year or every month or something like that, you got to split that percentage up for your multiplier for your growth factor based on how many times they do it that year. All right, we're going to see that happen in the course of this problem. Okay, so that nominal is huge. This is not the effective interest rate, this is nominal. All right, and there's a difference between the two things. So nominal is going to be split up based on how many times it's compounded in that year. Whereas effective, you wouldn't have to split it up. You could just multiply it by 1.03 for that year, and you know exactly how much it's going to grow in that year. But being nominal, that kind of makes a big difference. So we have a starting balance of 1,000, which is important, and any interest earned is deposited in the account. No further deposits or withdrawals. So just letting it sit. There's not any special situations. Okay. Our job here is to write the expression that represents the balance. So it's how much is in there at the end of a year, and they're compounding it annually. That means they're only doing it once. So you don't have to worry about splitting that 3% up for this first part. So you start with your 1,000. You know that's your beginning amount. You're going to be multiplying it. I'm using my asterisk for multiply so you don't get confused with the dots and stuff. So I'm going to be multiplying that by my growth factor here, which is 3%, 103%. And then we're going to be taking that to the power of number of times that we compound it, which in this case, it's an annual. So we're just going to do that one time. So this right here would tell us how much it would cost as an expression for just that 1 year, 3%. Now, number two, we're starting to think about this where it goes from a nominal interest rate into where we're breaking it down the number of times that it happens. Okay. So if interest is compounded semi annually, that means they're going to do it every 6 months. That's going to be twice over the course of that year. What interest rate would we use for this calculation? Now, we're not going to do 3% twice. It's 3% annual, right? But we're going to break that 3% up into two 1.5% sections. So the interest rate that we would be used for our calculation would be 1.5% because that's equal to the 3% split up amongst the two compounds. Okay. So that's how that works. That's the percentage that we're going to be using. And that's why in the expression, when we look at this, we don't want to use this one because they're using 3%, not 1.5%. These three are using 1.5%. Okay. So on this last one, if interest is compounded semi-annually, which expression would represent this account balance in T years? So we know that we're going to use this as our factor, which is why it limits it to these. And the thought here is how many times is it going to take place? How many times are we going to compound it? Well, they're all starting with the right number. They're all adding 1.5% like they're supposed to. This one right here is compounding it twice, right? 2 times. This one is doing it 6 times, and this one is just doing it t times. So in this particular case, we want to pick the one that's going to compound it twice. So that would be B. And to the number of years t, if it was 1 year, it'd be 1 power there. If they did it twice, it'd be 2. If it was 3, so on and so forth. So the correct choice here is B. A lot of people see the 6 there and they think because of the every 6 months, they think that's what goes there in the multiplier. No, it's the number of times. Okay, this is the number of times. Okay, compounded. We'll talk more about that, and we'll have a formula for it as well. The number of times that it's compounded. And then T, for 1 year, this is going to be good because you're doing it twice. But if it's twice, 2 years, then you're going to do that back to back. And that would be 2, and so on and so forth. So the correct choice here is B. And hopefully you can see why we're cutting out the 3% because we got to split up that 3% into It's, it's adjusted compound percentage, all right? And, that's all I got for this one, and we'll continue to work with compound interest as we move forward. Obviously, guys, if you have questions, I know it can be confusing about when you split it, how many times it's compounded, the exponent, yada, yada, yada. So, let me know if you have questions, and shoot me an email, ask me in class. That's what I'm here for. All right, later, guys.